Hi folks, so just going to quickly go over what we're building here. So we're going to call it HyperVault, and what this is tokenized HLP vault on the HyperEVM. So in Hyperliquid there's two parts, there's core and EVM. HyperCore is the perps DEX, it's also spot DEX actually. This is what people usually mean when they talk about Hyperliquid. But Hyperliquid actually has two parts, there's HyperCore and there's HyperEVM. So with HyperCore, is what people generally talk about when they're trading on the perp side of things. And HyperEVM is an EVM chain that we can permissionlessly deploy smart contracts to. The HLP vault is the main Hyperliquid liquidity provider vault on HyperCore. USDC is deposited by liquidity providers. Winning trades are paid out from the HLP, and losing traders lose their margin to the HLP. As we know, on average, over a certain duration, traders generally lose, so that's why people deposit into the vault, because over time traders lose and that goes to the liquidity providers. What we're going to be building a tokenized HLP vault on the HyperEVM. This means that we're going to need our smart contract on the EVM that can interact with HyperCore, and this is where precompiles and CoreWriter come in. So precompiles and CoreWriter. Our precompiles allow our smart contracts on the HyperEVM to read from HyperCore. So for example, we'd be able to read spot prices, perps positions, vault equity and so on. And then with CoreWriter, this is a great unlock. This allows us now to write from the HyperEVM to the HyperCore. So we can now swap spot tokens, we can open perp positions, and we can deposit into the vaults, withdraw from vaults and so on. And as you can see, that's how our tokenized HLP vault is going to work. How we're going to build it, we're going to use Soulmate library. So we'll use Soulmate library to implement our tokenized vault in HyperEVM. So Soulmate is a collection of different contract standards, and ERC 4626 vaults are the type of vaults that Yearn use and so on. And you deposit tokens into them and you hope that you get some yield back in the strategy. In our case, the strategy is going to be HLP, just depositing into the vault, and you're going to hope that over time the HLP produces a yield that we can then withdraw. We're also going to use a hyper-evm-lib. This is a new library created by OX1 and OXperiments from Obsidian Audits, and instead of calling the precompiles and CoreWriter directly, we're going to use their new library, which is great, and that's going to kind of abstract away a lot of the complexity. The Hyperliquid docs around precompiles and CoreWriter aren't great, and this HyperEVM-lib, to be honest with you, is a much better resource for understanding it, for seeing how it works, and I think everybody should look into the HyperEVM-lib on GitHub. This is just an overview of the flow. So on the left here we have our EOA, and that is, you can't see it there because it's in black, but it says deposit into our Hyper vault, which is an ERC 4626 vault, and that's on the HyperEVM side. We're going to use CoreWriter lib and a precompile lib to call CoreWriter and our precompiles over on the HyperCore side of things, and you'll see spot and perps are kind of segregated over there, and on our perp side of things we have our vaults which are going to deposit into. So essentially people are going to deposit from their EOA on the EVM. They're going to deposit USDC into the HyperVault, and in return they're going to get shares. And this is the key thing here, because you could really just go to the HyperCore side of things and deposit USDC into the vault, and you can take that out whenever you like. Hopefully you get some yield over time. But what we're trying to do is we're trying to get tokenized ERC20 tokens that represent your shares in the HLP vault on HyperCore, so that you can then use them in DeFi over on the HyperEVM. So that's what we're going to be doing. We're going to be depositing assets into the HyperVault and getting shares of that vault in return. Okay folks, we're going to set up our project. I'm using VS Code and Windows Subsystem for Linux, and I'm just going to create a new Foundry project. So forge init, create a new Foundry project. Just call my folder HyperVault. And I'm just going to remove these template files here. So you have the counter.s.sol, counter.sol, and counter.t.sol. You can remove them manually, or you can just go remove scripts counter.s.sol, t.sol. Okay, clear that. And I'm going to go git add, git commit, force commit. Okay, so that's just our basic skeleton done. And I'm now going to just get the install commands for installing the two libs. So we have our HyperEVM-lib for calling our precompiles and CoreWriter, and install that there. So it's forward install hyperliquid-dev/hyper-evm-lib, and I'll put that into the description of the video. That's done. And the next one is we're going to use Soulmate. I actually think this has been depreciated in favor of the Solidity library, but just for now, it doesn't really matter. An ERC 4626 vault will do anyway. So that's added in again. I'll put that in the description as well. So you have them in there now, and we now need to. I'm just going to get the contents of the foundry.toml from the project I've done previously. So okay, so I'm just going to paste in some information into our foundry.toml. So what we have here is our two remappings for the HyperEVM-lib and for Soulmate. I also have the testnet and mainnet RPCs. These are going to be in our env file, and this I'm not actually going to use this for verifying contracts, but I'm just putting it in anyway. Save that, and what I will do then is I'm just going to copy the actual remappings. We will create a remapping, touch remappings, text, and I'm just going to paste this in here. Okay, so we have our remappings in there, and we have them in foundry.toml. And okay, and then what we'll do is we create our env file. So touch.env, that'll give us our env file here, and I don't actually have anything majorly sensitive, so I'm just going to copy out these this details and paste them directly into our env. So my public address, you change that for your own public deployer address. HyperVault, we haven't deployed that yet. These are public RPCs, so I'm not worried about them being private or anything like that. And these are all public addresses as well. Obviously, they're blockchain addresses. And the token registry mainnet, this is deployed by the guys at Obsidian Audits who actually have created the HyperEVM-lib. I deployed this version to testnet. I'll talk about it later on. I'm getting a couple of issues with the precompiles and stuff like that on testnet. I don't know if it's a me issue or what's going on, but we'll talk about it later on. And I have a couple of token addresses and HLP vault address for mainnet. If you're using mainnet, on mainnet there is no USDC linked to HyperCore USDC, so I was tricking around with using the USDT before I switched back to testnet, and we just do USD from end to end, entirely from HyperEVM all the way over to HyperCore and back. Random vault testnet, just to let you know what this is. So on mainnet anyway, there is a 4-day lockup for hyper HLP vault, I should say. So if you put something into HLP vault, you can't unlock or you can't withdraw it for 4 days, okay? And I think we user creative vaults, they're 1 day. But on testnet, I still think they have the HLP vault the time gated, but the random, or sorry, with the user creative vaults, and this is one of them, they seem to have no lockup, so we can kind of test our project straight away by depositing and withdrawing. So that's why I have the random vault here. So we're theoretically building a tokenized HLP vault. In practice, we're actually building a vault for a random vault, but it doesn't really matter because from CoreWriter's point of view, a vault is a vault, and you just send the address and the amount you're sending in to withdraw or to deposit. So it should work fine. So that is our project set up now. So the very first thing I'm going to do here is I'm going to actually create a make file. And the make file is where our commands for deploying our contracts and for interacting with it are going to be. And I actually have them written up already, so I'm just going to copy them and paste them in. And what we'll do is we'll go over them afterwards. So click back into our make file. And here's the commands here. Don't worry about them right now, but we're going to be running them later on. As you can see, we're going to deploy, we're going to approve, deposit, and so on. And this is how we're going to interact with our contract. And the contract obviously is going to trigger CoreWriter. So we'll come back to that shortly. But firstly, what we're going to do is we're going to create our actual HyperVault.sol contract here. Okay, so HyperVault.sol. And rather than writing out the Solidity from scratch, I'm going to actually paste it in bit by bit, and we will walk our way through it to see what we're building. Okay, so Just gonna do this. There we go. So there's the bare bones of our contract. You can see our imports up here. And it's going to be our contract, our HyperVault is actually going to be in ERC 4626. We'll go over that briefly in a second, and you can see we're importing ERC 20, CoreWriter, and Precompile lib. So the way an ERC 4626 vault works is essentially you, the user, on the EVM, deposit assets into it. So in this case, we're going to deposit USDC, and when you deposit that into the contract, it's the developer's job to have a strategy in place of strategy of some sort that will gain you yield on that USDC. So it's that when you come back later on to claim your USDC, that you get more of it. So if you deposit 1,000 USDC in, you come back in a year's time, you want to have 1,100 USDC. And the way it works is that you deposit assets in, and you get shares in return. And your shares are actually ERC 20 tokens. So ERC 20 tokens in, ERC 20 tokens out. But the way it works is that it's a calculation done in the ERC 4626 contract based on the total assets that it's in possession of. Okay, and total assets is one of the main functions that we're going to override. And essentially, what you need to do is we need to account for every asset that our vault is going to own, and then as you can see here, all these conversions are done based on total assets, and that's how it works. So once we implement this and we say this is all our assets, whether they're on HyperCore or the HyperEVM or distributed across different protocols, if you have your total assets there, it'll take care of the calculations in your vault. Okay. So as I was saying, in the ERC 4626 implementation, there's three functions that we need to override, and they are the total assets ones that we just talked about there. That is the basis for all the calculations in our vault. But then we also need to override two hooks, which are called from within our deposit and withdraw function. So if you look in deposit here, happens is after these calculations are done, it calls after deposit, and this is a hook that we will actually implement the logic for. Similarly, if we get down to withdraw, you'll see that the calculations are done in the assets and shares, and then before withdraw, where we will put our logic. Okay, and if you go down here to the bottom, you'll see that they're actually down here, they're virtual functions, and we're going to override them in our main contracts now. So the first functions we're going to look at are after deposit, the after deposit hook, I should say, and total assets. And what we're doing here is we look at after deposit first. Okay, so what we're doing here is we have our total asset EVM count. Okay, I'm doing this now just for handiness sake. Ideally what we do is we'd call the precompile and we'd find out how much we have over in our vault, how much we have over in spot on core, and so on, and we do it that way. But as it's only kind of a small experimental project, we're just going to keep track of whatever is deposited into the contract just for now. But if you're doing this, if you're doing a bit more of a serious kind of implementation or project yourself at some stage, you'll want to take account of the possessions that the contract has claim over everywhere, whether that's in the HLP vault, in that it has in its balance in USDC on HyperEVM, or on spot or perps or whatever it is over on the HyperCore itself. Just to keep that in mind, we're just doing very, very raw, rough and ready, just adding the assets that come in and taking them when it comes out. So really you're not getting any yield out of this. It's really just assets into a vault, out of a vault, and so on. It's just to get the flow of CoreWriter and how HyperEVM interacts with HyperCore. So that's what we're doing there. And then as you can see here, we're using the CoreWriter lib to bridge the core. Okay, I'll talk about this now in 1 second. I just want to do the flow. We're doing the calculations of the core amount here, and then we're doing the USDC perp amount. So our EVM amount, I think, is 18 decimals. Our core amount is 8 decimals, and then the USDC perp amount is 6 decimals. Now, the guys who've written the CoreWriter lib and the precompile lib, One and Spearmint, they've done these calculations, but on testnet I'm getting an issue using the precompiles. I have deployed the token registry, which should give me back the correct information, but it's not. It's likely something I've done wrong, but for the time being, we're just going to do these calculations. We're just using USDC, and it's for now, just to get it working and see how things function, we're just gonna calculate these things here ourselves. Okay, so if you have a look here, just in this bridge, just to have a look really quickly, if you see in here, this is the precompile here. When I call this, I'm getting a revert. The transaction is failing. I'll look into it and try and get it working. But for now, we're just going to hard code this token index to 0. That's that on HyperEVM testnet, that's the token index, so that works fine for bridging over. This will work, and I'm taking out this check as well. Again, I have a feeling this is to do with the precompiles too. So I've taken this check out as well, and what we're doing essentially is we're just kind of taking out a couple of things just to get things working, and just to keep that in mind. Another thing to note is that on mainnet this will all work perfectly fine. You don't have to do any of this stuff here. This, which is again, like I said, it's likely to do with the token registry, but for now just trust me on this, that this is how we'll just get it working and get things going on it. Okay, and then as you can see, we're bridging over the core. So this will bridge our assets over the core, whatever we've passed over, and we then calculate the core amount, and we use that to calculate the USD per amount. Then over there we use this transfer USD class. So over on HyperCore we have two different classes, 0 and 1, or true and false. And essentially what it does is we have the spot side of things and the perp side of things. Okay, and we need, when we transfer this over, bridge to core, we're actually getting our assets over to HyperCore spot, and then we need to transfer them over to HyperCore perps, and then that's where the vaults live, and then you want to transfer it into the vault. So it's EVM over to HyperCore spot, from spot to perps, and then into the vault. Okay, so you can see the flow: bridge to core, then do our calculations, transfer it to perps, and then transfer it into the vault. Okay, as I said, what we're doing here is when we're doing a very rough and ready way here. We're just when we're depositing, we're adding the assets, and then when we withdraw it, we're just going to remove them, and that's how we're going to do our calculations. So our calculations essentially in this way are always going to be 1 to 1. It's going to be 6 in, 6 out, 8 in, 8 out for assets and shares. So the next functions we're going to look at are these. They are the before withdrawal hook, and the withdraw to user spot. Okay, and on the way over you'll see that we, like I said, we transfer from HyperEVM over to core spot. Then we go from core spot to core perps, and core perps into the vault. Okay, on the way back, logically it sounds like you should just reverse that order. Okay, that you withdraw from your vault, and then you do your USDC class transfer back to spot, and then you transfer it over. And we're doing a couple of things differently here, and I'll tell you the reason now in a second. Okay, so before withdraw is when you withdraw, hit the withdraw function, and the calculations are done on your shares and your assets. Then we're hitting the before withdraw hook. Okay, we convert our shares into withdrawal assets, and we decrement them from our total counts. And what we do is we're actually adding then the withdrawal assets onto this stage for withdrawal. Okay, and we'll go back to this in 1 second. Then we're doing our calculations, and we're doing our vault transfer. Okay, now you might be thinking, okay, why aren't we doing our USDC class transfer and then our spot send or our bridge back over to the EVM? And the reason is we're going to hit some sort of a race condition type of thing that wouldn't allow me to transfer from the vault and then subsequently in the same function call transfer USDC class and do a spot send. What was happening is that the vault transfer is being triggered, and then these two were being triggered, and they were failing, saying that we didn't have enough to withdraw, which to me says that the vault transfer didn't actually complete before these were hit, which is not the way it was on the way over. So we've had to separate them out. So what we're doing here now instead is we're just saying withdraw from the vault and tell me how much I can take out of the contract now. Now this works fine as a user, as a flow. It's not very elegant or anything like that, and I think you should probably think about what you'd like to do and what your use cases are, but it works anyway. Okay, so then what the user will have to do is call deposit, or call withdraw I should say, and then once that's done, they'll be able to withdraw to user spot. Okay, now just to say, we're not actually bridging back to the EVM here. What we're doing is we are transferring the USDC from perps back to core, and then we're just sending it to the user over on HyperCore. So it's going to be in the users on HyperCore spot itself. Okay, we're still getting it back, we're just not bridging it back to the EVM. So that's our contract there. Our ERC 4626 vault or HyperVault on the HyperEVM, and just to go back over the flow, we user going to call deposit on the ERC 4626. Then it's gonna trigger this after deposit hook, which is going to do the full flow EVM over the core spot the perps, and then into the vault. Okay, and again we're keeping track of our total assets here. And again, it's going to be 1 to 1. You're not really going to get any yield off it. I'll let you worry about that when you're doing your own implementation. And then on the way back, we're going to withdraw from the vault first, and then the user can come and claim their USDC back to their HyperCore spot account afterwards. So now what I'm going to do is we're going to save that and close it, and we're going to go touch script, and we're going to do deploy hypervault.s.sol. Okay, minimize this, deploy hypervault, and I have this done already. I'll just quickly go over it. Copy. There we go. So again, it's just a basic deploy script here. This deploy script, we are taking the random vault from testnet. On testnet, there is no lockup on user created vault, so this is why we can just deposit in and remove from the vault. So it makes it really handy. But like the same flow will do for HLP. But obviously, if you're doing stuff on mainnet, you're going to have to account for the 4-day lockup and the 1-day lockup. Really, here we just want to kind of get something raw working, to be quite honest with you. So what I'm going to do is that's okay there, and I'm going to switch over to my make file. So here's the make file, include env to make sure we have our environmental variables, and we are passing network testnet. I was tricking around on mainnet as well, but I just referred back to testnet for this. So what we're going to do is deploy HyperVault contract, and really it's just, you know, you've probably seen this before. It's just deploying the contract. So we're going to go make, and we're just going to let that deploy. We're going to take the HyperVault address, pop it in here in the EVM. And there we go. So after we've deployed our vault contract to the EVM, we need to activate it over on the HyperCore side of things. So to do this, we're going to just send a like $1 USDC over to it. So I'm just going to say 1, and we will say 0 and 7. There we go. Just going to send that. And you need to do this in order for the CoreWriter, for it to be activated to accept CoreWriter actions. So we're just going to confirm that. So we transferred over $1.07. I just made it a little bit of a weird one just to so we can see it in our command next. Okay, going to clear this, and if we skip back over to our make file, I'll have a command down here at the bottom. It's a bunch of cast commands and curl commands to get the EVM and core balances. I'm just going to do this, get all balances. Okay, should see 107 as our balance now in a second over. So there we go. So our HyperVault address on core now has 107. This my user wallet has this amount of USDC, and we've nothing in the vault currently. Okay, we also have nothing deposited into their HyperVault, and it has no USDC balance. I currently have $15 in the user wallet on the HyperEVM side of things. So what I'm going to do is, we have activated our account, we have deployed our contract, and we're going to approve. So we're going to approve, make, and we're just approving 1E18 here because it's just a largest number. That'll be plenty. Just give that a second to go through. So once we approve it, then we're going to deposit into our HyperVault. Okay, I have 15 in my account, and how much am I passing through? 7. So this is that's plenty. Okay, I'll transfer more over if needed. Okay, let's give that a second to go through. There we go. Gonna clear that, and we're just gonna go make. And we're just gonna deposit. So we're gonna deposit our 7 USDC, I think. Is that what I said? 7 USDC, yeah, into the contract. So give that a second now, and then what we'll do is we will check our balances. Okie dokie, there we go. I'm gonna clear that. What I'm gonna do is side by side. I'm actually gonna take I'm just gonna take this and make get all balances. Let's type it. Make get all balances. There we go. Now, see them side by side. So we should see that there's 7 E8 deposited into the contract. I should be have 7 E8, $7 less in my account, which is correct. 7 plus 8 is 15. And then if you see over here, we have the same amount here, but if you look down here, you see that our deposit vault here now has 7 USDC equity. So what's after happening there is we're after sending 7 USDC on the HyperEVM into the contract, and that's being noted there. Then what it's done is it's called CoreWriter. It's bridged it over to HyperCore. It swapped it to USDC perps, and then it has deposited it into the vault itself. Okay, so I'm going to close off the first one since this is our current state that we've 7 in the vault over on HyperCore. I'm going to do this. Okay, split this out. So what I want to do now is I want to do the rest of them. I want to do the withdrawal. So like there's no lockup, as I said, so we are going to the withdrawal. So we deposited 7, we're actually going to withdraw 6, just to kind of keep a little bit of balance in the file to show you exactly it's working. We're going to go make this kind of a badly named withdraw USDC from HyperVault and Core. It's actually been withdrawn from the, I suppose, the HLP vault or some random vault, but we'll just go with it anyway. Okay, you get what I'm coming at from there. So what this is going to do is the only thing that's going to change here really is going to be the USDC equity in the vault on HyperCore is actually going to get down to 1 because we're removing 6, but it won't show up in any of the balances except for that. You're just going to see 1 down there instead of 7. Give that a second. Here we go. And yeah, we'll just check our balances again now. So if you get our balances now, you should just see that this has changed here. This here 7 has changed to 1. Hopefully, there we go. Everything else is the same. Yes, sorry, everything else is the same except for assets deposited. Yeah, because I've decremented that in the withdrawal functions. That is correct. That is correct. So ignore me there for a second. Good. So that's grand. So what I'm going to do then is, so what happened here now is, as I said earlier on in our HyperVault, when we called our withdrawal function, it's withdrawn, it's done the withdrawal, or it's done the vault transfer, and it's actually staged for withdrawal. So we should be able to withdraw now into our, we should actually be able to withdraw it over to our wallet on the HyperCore side, HyperCore spot side, I should say. Okay, so let me see, 1 second. I'm going to make file and stage. We do the stage for withdrawal check. It's really quick. Close this off because that's not the state anymore. So we're going to go with this one. I'm going to go make. So this should say 6E8. There we go, 6E8. And as we said, this was saying 7E8, but we've decremented it by 6E8, and that's ready to rock now for us to withdraw from the vault. So I'm going to now. We're going to actually withdraw it so it's currently in possession. It's currently in possession of the HyperVault contract address over on HyperCore in its spot balance, and we're going to do a spot send to our account over on HyperCore spot. So give that a second to just go through. What's going to happen now is this is actually going to go up. So on HyperCore, our spot balance is going to go up to 190, what is it, 192.33, I think. So try again. And we should see it now. There we go. So 291. So actually, yeah. So what I've done, did I withdraw? I think I might have withdrawn 5 there actually. So let me just check. Stayed, yeah. Sorry, we withdrew 5. So put 7 in. We withdrew 6 from the vault, and then we actually transferred 5. All right, this is just to kind of have different numbers to leave a little bit in each one. So you can see that we still have 1 in there. We still have 1 in there, and we now have transferred it back. So you can see generally how the flow is working there, and it's working pretty good. There's another couple of things I just want to show you really quickly. So just going to minimize these, close my make file. So we've done the full flow. There's just another thing I want to show you really quickly, and it is to deal with the vault transfer. So we click over here. So on testnet, there is no lockup. This locked until timestamp, I think on testnet, I have a feeling it's in the past. So what ends up happening is that this ends up reverting. So I normally wouldn't, I don't like messing with the libs because they work perfectly fine on mainnet. But to get this working on testnet, I kind of needed to do a couple of things to it. So I just want to point out where I've actually changed things here. I've removed this is deposit check because yeah, because there is no it is not deposit, I should say, because the locked until timestamp on the testnet actually doesn't calculate correctly, because it's there's no lockup essentially for those vaults. Okay, it might be different for HLP vault on testnet, I can't remember now, but I've commented it out anyway, and you won't get an error in there. And the other ones, of course, are up here at the very top, I believe. So what we have is, yeah, so I've hard coded in the USDC token index here because the precompiles are doing something strange. Not really sure why, because when I call the token registry with the EVM address, with my EVM token address, it does return 0, but for some reason it's not working properly. I'll have to investigate that and get it working, because I don't really want to be, I want this stuff to just work, and you know, these guys know what they're at, so this is I want these things to work. So I'll get around to that, but in order to get the video done, to give a bit of an illustration of how the entire flow works, I had to do a couple of things like this. So I believe that's it now. What I'll do is this. I'm gonna push this repo up to GitHub. I'll put any resources. I'll put any resources in the description or in the repo. I'll give you links to the lib. So I'll also give you links to some articles and so on that I used. The Discord is very good. In fact, I found the Discord probably better than the Hyperliquid docs. The guys are very knowledgeable in there. So yeah, look. I hope you got something out of this. It works. There's a couple of little bit of kind of hacky bits in it, but look, we'll try to clean them up the next time we're implementing some. Thanks very much.